Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the values for a resistive capacitive series complex circuit from the Chapter 17 math handout, problem number 17. So this is called a complex circuit. Not combination, but complex, because it uses two different types of components in the same circuit. It's called a resistive capacitive complex circuit because it has a resistor and a capacitor. Alright, I'm taking my known values from the Chapter 17 math handout, problem number 17. And I'm using the formulas from the Chapter 17 formula handout. Now make sure when you're looking at your formula sheet that you only use formulas 14, 15, 16, and 17 for the series complex. Do not cross this line over here and use any of these formulas for a series. And vice versa. When we're doing parallel, don't cross this line and use any of these. And I'll show you how that's an easy mistake to make in a future video. Alright, so my first step, I'm going to fill in all of my currents because current does stay the same in a series circuit. Formula 15 shows me that my current will stay the same. I was given 20 milliamps, so I know that I can fill in all of my currents. The next step that I'm going to take, I'm going to calculate my ZT using formula number 16. So I'm going to open square root, and I'm going to punch in my R value of 2K ohms, and I'm going to square that, plus my capacitive reactance value of 1.5K ohms. I'm going to square that, and I'm going to get an answer of 2.5K ohms for ZT. And Z stands for impedance. Whenever we have reactance and resistance in the same circuit, we have an opposition to current flow called impedance. Alright, inside these parentheses we can use Ohm's law, and I want to point out to you that you see that you have some different electrical quantities here, and you must memorize these for the test. This OZ here stands for theta Z. Alright, so the first thing I can do is calculate my VC. I'm going to take my 20 milliamps times my 1.5K ohms. That gives me a VC of 30 volts. I'm going to take my 20 milliamps times 2K ohms to calculate my VR of 40 volts. Now, what I want to point out to you here, and why I did it in that order, is to show you that you cannot add VC plus VR and get the correct VT number. You have to use formula number 14 because the voltage that goes through the resistor and through the capacitor go through there at different times. They're out of phase. So you can't just add them up. Now we could do the 20 milliamps times 2.5K ohms and get our VT of 50 volts. But 30 plus 40 is 70, not 50. So make sure that you can use Ohm's law, 20 milliamps times 2.5K ohms to find it. Then you'll find these two using ohms. And if you want to check your work, you can check your work with formula 14. Open square root, put your VR value of 40 volts squared plus VC of 30 volts squared, hit equals, and you can check your work that way. The last calculation we need to make is our theta Z, we look at formula 17, and if you look closely, it shows us actually inverse tangent. So we're going to go shift tangent. Make sure you hit shift first. Shift tangent. We're going to open parentheses. I'm sorry, you don't have to open parentheses. Let me start over. Shift tangent. All right, then we're going to hit the negative symbol. We're going to punch in our XC value of 1.5 times 10 to the third over under our R value of 2 times 10 to the third. Scroll over, close parentheses, it equals, and it's negative 36.87 degrees. Now on your homework and on the test, you do not have to type in degrees. Just type in, make sure you do negative though, 36.87. You don't have to try to type in the degree symbol. Alright, so we've got that answer. And as we've always done with resistance, you don't have to type in the ohm symbol, you just have to type in the numerical value of 2.5 and your metric prefix of K. And for my total voltage, we're going to put our numerical value of 50 volts. Now if there was a metric prefix involved here, yes, you would have to put it. Alright, hope this helps you. Thank you.